I'd like to introduce Kaizen's own Vice President, Erik Miller.
Thank you, Cassie, and thank you everybody for joining me today. So today we're going to talk about foaming in your cleaning process. And what is foam? Foam is really bubbles. And in our domestic life, foam and bubbles are there to show us that the cleaning material and the cleaning chemistry is there to do the job that we're wanting it to do. I resisted the urge to put in pictures of hand washing given the current environment, but anyways, it's there to let us know that it's doing the job. However, those bubbles become problematic when we move into cleaning into any equipment, whether that's domestic or in our professional lives. Can even be a little bit too aggressive and cause some really big problems. So today, we're really going to be talking about reducing and eliminating foam before it even starts. So in an electronic cleaning process, we're typically talking about a batch or an inline process, and those processes typically use spray, might be a high pressure or a high flow, but it's a spray nonetheless. Typically, within the pump, there's a lot of shear forces, which has the potential to create a lot of foam. And in some of these processes, the bath can turn over completely in as little as 30 seconds. So we also have to consider the drag out and the cross contamination and make sure that we are controlling that so that we don't get foam. And as you've heard in some of our previous tech to tech, you're only as clean as your final rinse. And so this can be an indication of how much foam or cross contamination you're getting as well. So the process is simple enough. We've got to wash often the source of some foam. We have a rinse, which is where we typically find foam the most often. You have a final rinse where you can really not tolerate very much foam at all. And then the dry, the worst thing that can happen is we could actually dry foam onto the surface of something that we're trying to clean. So the process is quite simple. So the idea is to identify the sources of our foam. And I'm going to give you a little moniker to hopefully help you remember this, but we need to look at the filth. We need to stay organized. We need to understand what's going on with the air, and we need to monitor the process. And let's talk about each one of those things. So if we talk about filth, it's really knowing the source of your outside soils and your outside contaminants. And so what do I mean by that? I mean your incoming materials. Beyond the cleaning chemistry and the cleaning material, what else is being introduced into your wash bath or into your process? That could be simple things like fluxes. It could be different salts from fingerprints or other processes. Can even be oils at times. The filters tend to collect those things. So there's rinse filters, there's air filters, there's wash tank filters, but the filters tend to collect these incoming raw materials and often can be a source of foaming if they're not cleaned or replaced on a regular basis. And likewise, your nozzles, whether that's a spray nozzle or an air nozzle, can get clogged or obstructed by something that's coming in from an outside source or an outside contaminant. If we look at organized, what do I mean by organized? This is where we're looking at controlling our drag out and controlling our cross contamination. And that comes in a number of different things. First off, you've got boards that are in a process. And this is an example of boards on a inline process where they're well spaced out. There's plenty of space in between for things to drain and not contaminate one process to the next. This is important in batch as well, and we'll talk about that a little more later. You've got carriers that are used, and here's an example of two good carriers where your parts are separated. There's ample space for drainage. You're not contaminating from one section to another. You're not carrying over large amounts of chemistry or rinse water or whatever from step to step. Baskets are often used or commonly used. This is an example of a good basket that has ample drainage. It also shows that the parts within the basket are spaced out well and not going to be carrying contaminants from one process to the next. Pallets are often used and are by design tend to obstruct lots of things. But this is also a good example where the pallets are well spaced. They're set up so that there's ample drainage. We're not getting bridging from one process to another. So again, we're not contaminating other processes or other steps in the process. Curtains are also important and the quality and the overall look of the curtains can be important. So a solid curtain coming into a section and a fingered one going out is often the recommendation, but making sure that they're well maintained, they're clean, and in doing the job will save you a lot of trouble as well. Spray angles can be really important. It's nothing worse than your wash section spraying directly into your rinse section, or your rinse section spraying into your wash section. So minor things like the spray angle need to be paid attention to, and they can avoid a lot of cross-contamination and drag out. Also, parts are often racked, and so this is an example of some connectors. This is a good example because the connectors are facing down, not up, where they could be little cups to hold materials from process to process. This is also a good picture in the fact that the parts in the rack are not shadowing each other or covering each other up. So you're getting good coverage in the cleaning, but also good coverage or good positioning so that we're not dragging out or cross-contaminating. Next, we need to look at the air. We need to understand the airflow and make sure that the airflow is proper so that we're eliminating and reducing foam. The exhaust is often a source of foam, and what's common is that the unloading section of a machine often has a much higher draw. That's because that's where it tends to have people, but that will also pull chemistry and foaming materials from one section into another section, and it kind of happens drip by drip, but it's a large contributor to foam, and making sure that your exhaust is balanced so that we're not pulling one section over another is very important. Air knives are also a very good source of foam or the prevention of foam. If your air knife angles are not correct and we're not moving material back into the section that it's coming out of, we can often contribute to drag out and cross-contamination, and it will increase the foam levels. Pumps are also something that we need to pay attention to. It's not necessarily part of the airflow directly, but pulling in air into the chemistry or the water can often exacerbate the foam. And so that's kind of like turning the jets on the jacuzzi. If you've got a few bubbles, it doesn't do much. But if you've got lots of bubbles, all of a sudden you're going to have a big problem. And then finally, we need to monitor. You know, you've set up a process and it has parameters for a reason, but we need to confirm those. You know, the modern chemistries are pretty flexible, but oftentimes if they drop too low in concentration, they can contribute to foam. So are you confirming the chemical concentration that you set? Temperatures can be a big part too. If you're too high or too low, typically too low will create more foam. Sometimes people will try to save money on rinsing water, and they'll use cold rinse water. That shock in temperature can often create additional foam. So making sure that your temperatures are set correctly. Your tank levels, back to that pump idea. If your tank levels are low and you're pulling air into the pumps, that just exacerbates the foaming potential. So making sure that your tank levels are at the appropriate levels. Pressures, they can often indicate that you are getting foam or starting to get foam, or they may be too high or too low. They can contribute to the foam. So just confirming that those pressures are where you want them to be set is really important. And then finally, your final rinse quality can be a very good indicator of if you're getting any drag out or cross contamination. It's a process that's very often monitored in cleaning, in electronics cleaning. And so it can be a very good indication of how your overall process health is in terms of foam and in particular cross contamination and drag out. So it's pretty easy to eliminate foam. You just need to understand what's coming into your process, what those contaminants are. You've got to stay organized and make sure that we're reducing and minimizing cross contamination or drag out. Making sure that our air flow is balanced and not pulling chemistry one direction or another, or creating foam from one section to another, and monitoring the process, confirming that your set points are what you're actually running in that process. It's pretty much that simple, but if you do those things, you can pretty much eliminate or reduce foam completely. I want to thank everybody for their time, and if there's any questions, go to those.
Thanks, Eric. If you would like to discuss this topic further, please contact your local Kaizen regional manager or send an email to tech@kaizen.com, and we will have someone schedule a follow-up with you as soon as possible. Again, we thank you for taking the time to join us today, and we hope to see you again. Stay safe, stay healthy, and have a wonderful day.